This video is about options for return trajectory for a crewed mission to Mars. There are pros and cons with the alternatives, but considering the long time it takes for a one-way trip, it is a high priority to shorten the total time of the mission. Welcome to Virtual Pathfinder channel. I make videos about imaging and especially astrophotography. If you're interested in exploring the universe with your camera, remember to subscribe to this channel. I use affordable equipment which can reach distant galaxies as well as detailed structures on the moon. Now let's get back to the Mars mission trajectory. As I mentioned earlier, the most energy-efficient way to go between two orbits around any object is to enter the Hochmann transfer orbit between the two orbits. That is not the fastest way to reach the destination, and to go to Mars takes about 7 months. The problem is that to go between Mars and Earth, the planets must have a certain alignment, which is called the launch window, and it comes with 26 months intervals. That is over 2 years. There are two categories of Mars missions defined by how the planets are aligned at departure. Mars and Earth departure can either be in an orbital position close to each other, which is called a conjunction class mission, or the planets can be at opposite sides of the Sun at departure, which is called opposition class missions. To use the Hochmann transfer orbit would need to be a conjunction class mission. That would have a total mission time of up to 3 years due to the long waiting time of about 1.5 years before the next transfer window occurs. Then the travel time in each direction would be about 7 months. The total mission time would then be 2.5 to 3 years. The opposition class missions use a trajectory which is very different from the Hochmann transfer orbit. One of the alternatives is known as Crocos Multiplanetary Trajectory, or Crocos Grand Tour. It is named after the Italian scientist Gaetano Crocco, who proposed that trajectory in 1956. It can be used for a non-stop mission, including flybys of both Mars and Venus on the way back to Earth. Such mission does not include a visit to the surface of Mars, but it could enable a closer look at the planet's surface, and the total mission time would be 1 year. For a crewed mission to Mars, including a landing on the surface of the planet, Crocos Grand Tour can be used for the return journey. That trajectory would start from Mars, then cross Earth orbital path on the way to Venus, which is closer to the Sun. After Venus flyby, the spacecraft would then enter an orbit closer to the Sun before once more crossing Venus orbital path on the way to Earth. The passage near Venus is not a gravity assist, it is rather a way to counterbalance the gravitational effects from Mars gravitation using the gravitation of Venus. By balancing the gravitational effects from the two planets, a spacecraft can be directed along a trajectory towards Earth. Also, by using this trajectory, the long waiting time for the next transfer window can be reduced from 18 months down to about 1 month, which would dramatically shorten the total mission duration from about 3 years to 1.5 years. With the opposition class return trajectory, one may actually wonder why the total mission duration doesn't take a few months shorter time, since the transfer time is about 7 months in each direction, which would mean a total of 14 months travel time. If the waiting time on the surface of Mars is just 1 month, then the total would be 14 plus 1, which is 15 months. But the actual travel time is about 18 months, and there are reasons for that extra months of travel time. It has got to do with a longer return trajectory with crossings of both Earth's orbital path as well as Venus' orbital path. The gravitation of the Sun, which creates a gravitational well, drags down the speed of the spacecraft when going from Venus orbit towards Earth orbit. That stretch is uphill from gravitational point of view, since Earth is in a higher orbit around the Sun compared to Venus. Partly that is compensated for by the gravitational downhill trip from Mars to Venus, but the longer trajectory and the stronger gravitational pull from the Sun makes the return trip about 12 months long, which is almost 5 months longer than the outbound trajectory. So in summary, the pros of this opposition class mission are that the total mission time can be cut in half, and that it also provides an opportunity to have a closer look at Venus. The stay on Mars can be cut down to about a month, which is sufficient for a first mission. However, the cons are that there will also be a longer time spent in weightlessness during the trip, which is a huge risk from human health point of view. There is also a risk for longer exposure to radiation such as galactic cosmic rays and solar particle events, which both create a risk from health point of view as well as the functioning of the electronics on board. There is the passage close to the sun, which may cause extreme heat. To handle that requires effective heat shielding and design to withstand the higher temperatures. The opposition class missions also require a lot more fuel since the delta V is higher. Although the return trip along the Crocos Multiplanetary Trajectory is interesting, it may not be the first choice, since human health has the highest priority for a successful mission. It remains to be seen what the conclusions will be, but regardless of which choice is made, this kind of crewed mission is far more complex than going to the moon. Many unmanned missions to Mars have been launched before, and some are active at present. Unmanned missions to Mars is not new. The main difficulty this time is to bring humans to Mars and back in a safe way, which is a huge challenge. That was all for this time. I hope you enjoyed this video. If you're interested in space exploration, remember to subscribe to this channel. I will release more videos about issues related to the future mission to Mars, as well as the ongoing lunar missions. I look forward to see you again in the next video.